Okay, so let's take a look at our problem statement for our next program. And whenever we develop this particular program, we'll look at a lot of the technical details in terms of defining our own type. So we want to write a program that models a virtual pet. So we'll assume that the pet has a weight and it can also be in a state of being hungry or not. And we can also feed this pet. So whenever we feed the pet, if the food weight is greater than or equal to 1/2 of the pet's weight, the pet will not be hungry. Otherwise, it will be hungry. And the weight added to the pet will be 1/4 of the food weight. So as we look at this problem statement, we can start thinking about the attributes or the properties or the state information associated with this virtual pet. So this virtual pet has a weight and it also has a state of being hungry or not. And we have this operation of being able to feed the pet, and whenever we feed the pet, it results in changing possibly the status of it being hungry or not, and it definitely affects the weight. So the weight is again changed by adding 1/4 of the food weight. So this is a very simplistic virtual pet right now. Later on we may come back and add in additional functionality to it and additional state information where we can possibly walk the pet or perform some sort of exercise where it can lose weight as opposed to just simply gaining weight as we feed it. So whenever we write this program, we'll probably make a few mistakes and it won't be perfect the first time through, but that's traditionally how things occur whenever you're developing a program. You come up with a design, implement that design, and then hopefully refine that design and make improvements upon it. So let's go over into Eclipse and start writing this program. Okay, so we're going to call this program Program 7. So I've already created a Program 7 project folder here. If you need to create one, you can pause the video at this time and do that. So go ahead and right-click on the Program 7 project folder, go to New, and we're going to select Header File. So go ahead and left-click on the header file, and we're going to specify that the name of this header file is just simply vpet.h for our virtual pet, and we'll select default C++ header template, and then click on Finish. So here we have our header file. We've already got the name associated with it. We also have these pound if not defined guards in place. So we discussed that in our last video. So these are just to ensure that we're not doing multiple includes. So this just pops up automatically. And it's good to have these. So this prevents you from, or aids you in not having to actually type this in. So let's go ahead and talk a little bit about what we want to do here in the vpet.h file. So in the header file, we're going to be defining our interface for this thing that we're trying to define, this virtual pet. So in C++, we have this construct called a class. And a class allows us to define a blueprint or a template for describing something in terms of its properties and its operations, its attributes and operations, however you want to define those things. So let's go ahead and define a class called vpet. And the way we do that is just simply use the keyword class, and then we specify the name, and almost just say vpet. And then I'm going to use open brace and then hit enter, and we should get a close brace, and it should have a semicolon at the very end. So this is just the syntax that we need to be using there. So whenever we define a class, we have keyword class, the name of the class, open brace, close brace, and then a semicolon. And here inside of this, we'll actually describe the members of this particular class. So the members can be data members or they can be function members. That's generally the classifications that we can have. And also in addition to the data members and the function members, we can divide things up in terms of what's public and what's private. And what do we mean by that? So when we say something is public, we're saying that it's going to be available to the client of this particular class to use. And if we say something is private, we're saying that that thing is not available for them to directly manipulate. So if we go back to the example of our bank account, we probably want to provide them with a mechanism to be able to make deposit and withdrawals. So we'd want to have that functionality publicly available. Whereas if we're talking about the actual amounts that they had in checking and savings, so we may have some variable that represents how much they have in savings or how much they have in checking, we wouldn't want to allow them to directly manipulate those values. They could only manipulate those values through the interface, the public interface of doing a deposit or withdrawal. And it's going to be something similar here with our virtual pet. So let's go ahead and define the public part of our interface by using this keyword public and then a colon. Okay, so come down a line. Looks like the auto formatter here is putting this in the first column, but I'm going to tab this over. I probably need to change that. So go ahead and type in public, come down a couple of lines. And one of the first things that we'll provide to the user is a way to actually construct a new thing of this type. So we'd like to be able to create a new virtual pet. So this particular thing is what we call the constructor, and we'll just simply call the constructor vpet. So it turns out that anytime we have a function in which the name is the same name as the class, you'll see that our class here is called vpet, and we're defining here a function called vpet. Those particular functions are called constructors, and they're basically what's allowing us to initialize a new thing. So in our case, the constructor is going to have a couple of parameters here. We'll have one parameter for its weight, which will be of type int, and we'll have another parameter which will be of type boolean, which will be our hungry parameter, which basically tells us whether that particular virtual pet is hungry or not. And we will also like to have the ability to construct a pet that maybe the user doesn't supply the weight and whether they're hungry or not. So we'll just define another constructor here, so you can have more than one constructor, and this will be our default constructor. So when we actually go in and create a source file that has all the implementation details, we will define some default values for the weight and whether the pet is hungry or not if the user decides to create a virtual pet and doesn't supply that information to us. Okay, so these things again were just simply our constructors. So one thing that we need to keep in mind here as we're writing the interface here is that we are defining a template for a certain thing. So what that means is that we'll be able to create as many virtual pets as we like, just like we could create as many bank accounts as we'd like. All right, so let's go down. And the next thing we're going to do is actually create just some functions. And we'll just label these as member functions. Technically, the constructors are also member functions as well. They're just special type of member functions. So maybe I'll write that comment in here as well. So go back down a couple of lines here where we have this comment, member functions. And we know from the problem statement that we would like to be able to feed our pet. So we'll just simply call a function feed pet. And we'll need to pass in the amount of food that we want to feed the pet. So I'm going to specify that that's going to be an integer value, and we'll just call it amount. This particular function is not going to return a value. It will be manipulating the weight, but it won't actually return anything. So we're going to have this as a void function. All right, so our next member function that we're going to write is just simply a function that returns whether our pet is hungry or not. So it's going to return a Boolean value, and we'll just call it get hungry. And it just simply gets the state of our pet, whether it's hungry or not. And then we'll also have another integer value that gets the weight. So we know that we can change the weight as we feed our pet. So every time we feed this pet, it's going to grow in some size. So we'll say get weight. That's the name of that function there. All right, so those are our member functions that are not constructors. And now we're getting to the point in our class where we're going to define the private parts. So I'm going to label that private. So that's another keyword in C++. And here we're going to have a lot of our what we call data members. So in general, the data members in our class will be private. And we don't want to have direct access to these. So in this case, we'll have a data member for weight, which will be of type int, and we'll also have one that's of type bool that we'll call hungry. So whenever we go and write the source file, we're going to be writing the implementation details for all of these things here, but in the case of our member functions, whenever we feed the pet a certain amount of food, then that will actually manipulate and change the weight. And also, depending on how much food is fed to the pet, it will change the status of whether the pet is hungry or not. So let's go ahead and write the implementation for all of these declarations here. So that we're going to go and actually write the function definitions in a separate file. Okay, so go ahead and save the vpet.h file. And now we're going to actually create the source file. So right click on program 7, go to new, and then go to source file. And now we'll just name the source file vpet, vpet, not vip, vpet.cpp. And the template can be none, and click on finish. So the first thing that we'll do is bring in or include this header file into our source file. So we'll do a #include and then specify vpet.h. So what's going on here is whenever we compile this program, there's a thing called the preprocessor, and it actually brings in all of this stuff here. So effectively all this stuff is being pasted into the very beginning of the CPP file. Okay, so now let's look at actually writing our first member function, which will be for the constructor. And whenever we write a particular member function that's not inside the class, so we can see that we defined our class here in the vpet.h file, but we'll be defining the definition of those particular member functions here in vpet.cpp. And we'll have to specify what class we're actually referring to. And the way we do that is just specify the class name and then : : So once we do that, Eclipse is helping us out here and actually providing us a list of the member functions associated with the vpet class. So once we've done that, we'll just simply select the constructor here. And remember that the constructor is designed to initialize our data members. So our data members were for weight and also for whether it was hungry or not. So I'm going to just say int w and bool hun, okay? And here, after that, we're going to do what's called an initialization list. So I'm going to have a colon, and then I'm going to specify the data members. So our data members, if we look back at vpet.h, was weight and hungry here. So this weight and hungry that we're specifying here is different from this weight and hungry here. We didn't even have to specify these values here. We could actually get away with just simply having int and bool here. It doesn't really matter there. We were just specifying the types here. This was a function declaration, and now we're specifying the function definition. Now in the function definition, we do have to actually specify some name associated with the type because we were actually introducing these variables here. But these variables are just allowing us to pass in information. So whenever we go and create a new virtual pet, we will be able to invoke or call this particular function, this constructor here, and pass in values for the weight and whether it's hungry or not. And depending on those values, we can initialize our data members here, so weight and hungry. So the way we can do that is through an initialization or initializer list. So right after the function header, so all this stuff here is the function header, then we'll have a colon, and then we can specify weight being one of our data members, and then specify the variable here w, and then come over, comma, and then we'll specify hungry and use this particular variable name here called hun. And that, let me come down the line and do an open brace, close brace. So what we've effectively done here is created our constructor. And you can not have an initializer list. So what we've done here could be represented similarly. I'm going to cut this out for right now. We could similarly write the same thing by saying the data member hungry and assign it, let me do weight first. The data member weight and assign it the value of w, and then also having the data member hungry and assigning it the value of hun. So that's equivalent to what we had before. The only difference is whenever we call this constructor here, you're initializing it with some default values, and then you're overriding those default values. Whereas if you have the initialization list, it's not doing this this write operation to initialize this weight and hungry twice. Effectively, whenever we don't have the initializer list and we do it this way, we're basically doing an operation twice that we really shouldn't be doing. So the quicker way to do that is just to have the initializer list like this. So I'm going to get rid of that. That's the preferred, more elegant solution. The other thing is that you could actually have some situation in which maybe the constructor is being used before these values are properly initialized, where if you have the initializer list, you know you're getting a proper initialization straight away when it's created before you even go back and try to do anything else. All right, so let's move down a couple of lines, and now we'll do our other constructor, the default constructor. Remember that the default constructor doesn't have any formal parameters specified here, so don't forget that these were called formal parameters. So no formal parameters, and we'll have an initializer list, and we'll specify weight again, and we'll say that if the user doesn't specify a weight, we'll just assign a weight of 100. And these could be 100 pounds, 100 kilograms. It really doesn't matter. We're just using some value there. And then we'll say hungry, and we'll specify it as true. So if they don't supply us a weight or a hungry value, then this is what we'll have. Again, we need to have that open brace, close brace there, because this is a function. It's just that we don't really have anything in the function body. The other thing that you'll notice about these constructors is that they don't have a return type. So in addition to the constructor having the same name as the class, so VPET and VPET here, they also do not have a return type specified. And let me be clear by saying that this is the case for all constructors. It's not just simply our VPET constructors here. So any particular class that we create and the associated constructors will not have a return type.